Hi everyone, welcome back to Array series. Hope you are doing good. This is Mahesh. In this video, we will continue on the maximum product subarray. So basically, this is a continuation of the previous video where we already discussed the brute force solution, the better solution, and one of the most optimal solutions. So in that video, we already discussed that there will be two optimal solutions for this particular problem. So one we have already seen in that video. So I recommend please go back to that video and watch all the three ways and then come back to this video. So in this video, we will look into the second optimal solution, and also we will try to understand which one is better or when to use which optimal solution. So with that, let's get started. So here we will use basically the DP approach, or it is also called cadence algorithm like algorithm. Okay, so why it is called so? Why it is a DP approach? Because we try to remember the previous maximum product, whatever we got. So for that, I mean, it is similar to the cadence algorithm which we used for maximum subarray sum uh, solution. So in the maximum subarray sum solution, what we did, we kept the or we memorized what is the maximum sum till now. I mean, whenever we are trying to process any element in the array, so we always keep the reference of the previous maximum sum. So that way we keep remembering the maximum sum, right? So here also we will do the same. We will try to remember the maximum product. That's why it is also called DP approach. And since I mean it is similar to like cadence algorithm, so it is also called cadence like approach, cadence algorithm like approach. Okay, so with that, let us try to understand this solution. So basically we will try to memorize the previous maximum product, and along with that we also need the previous minimum. So we will track, basically we will track the maximum product and minimum product. So why minimum product? So this question rises, right? Why minimum product? Why? Because we know from the constraints that this particular array contains negative numbers also. So what it means, if at all it contains negative number, that too multiple negative number, so maybe one product, it might be very negative when we multiply it with one negative number, but on the occurrence of the next negative number, it might turn out to be the maximum product, correct, right? Say for example, we are trying to find the product. Maybe product is somewhere minus 20, and then we find another number which is 2 or something like that. So if you multiply this with minus 2, then it becomes 40, right? So it will be a positive number. So there is a chance that this number will contribute for our maximum product. So keeping that in mind, we will try to memorize the maximum product and also minimum product. So let us look into this example. So what I will do, I will take the number. So this number is basically the number that appear in the array, like one after the other. Then I will say what is my current maximum product, current max product. Then I will also keep track of current min product, and finally we will try to update our max product here. Okay, so now what I will do, I will first consider the first number. Let us assume that will be the current max product, and that will be the current minimum product. So if assume there is only one number, then the possible max product would be that particular number, right? So what I will say, I will initialize my current max product with the first number that appears in the array. Then minimum product will also be the same. Okay, and if you see the maximum product, that will also be 2, correct, right? So Now with this initialization, let us start processing the elements. So now I will take my number, so which is 3. Now you compare this number and also you compare this number with the previous product and multiply with that number. So basically I will compare my 3 comma 3 into 2. So this is 6, right? So whichever is maximum out of 3 and 6, that I will take. So basically I will take 6 as my current max product. Then my minimum product, again I will take the current number and I will check by multiplying it with the current minimum product, which is 2. Okay, so out of this, which is minimum, 3 is minimum, so I will take 3 as our current minimum product. Now if you see, if you check the current maximum product, it is greater than our maximum product, so I will simply update my max product. Okay, with this, now what I will do, I will move to my next number, which is minus 2. Okay, now whenever you see any negative number, now what we need to do, we need to swap the current max product and the current minimum product. Why? We already discussed, right? I mean, whenever a next negative number occur, or at any instance whenever a negative number occurs, it might change our scenario, right? Whatever was the previous minimum product, that may come out as a maximum product. That's why we need to swap. So what I will do, I will simply swap them before proceeding further. So I have swapped. Then what I will do, I will take current number minus 2, then I will multiply it with my current max, minus 2 into 3, which is minus 6. Correct, right? Now out of these two, which is maximum? Minus 2 is maximum, not minus 6 here. Okay, because these are negative numbers, so I will take minus 2 as my current max product. Then our current min product will be minus 2 comma 6 into minus 2. Okay, so this becomes minus 12. So out of minus 2 and minus 12, which is minimum? Minus 12 is minimum here. Okay, because that's a negative number. So now if you see, our max product won't get updated because 6 is only the maximum as of now. Okay, now let us consider the next number. We'll take 4. Now if you see, 4 comma 4 into minus 2, so this becomes minus 8. Out of these two, which is maximum? 4 is maximum, so I will take 4 as my current maximum product. Then I will check current minimum product. Now it is minus 12. Current number is 4, and then minus 12 into 4, which is minus 48. So minus 48 will be our minimum. So I will take minus 48. Our max product will still be 6 because this is less than 6. So it will be 6. So that's how we find the maximum product. But wait, now I will modify this a little bit. Why? Because we want to understand why we swap whenever we get negative number, right? We swap the numbers here, right? We swapped here. So why is that case? Let us consider this minus 1 now. Now the scenario will change completely. So now once I get minus 1 as the next number, now before proceeding, what I need to do, I need to swap the max and the current max and the current min. So I will do that. So this becomes minus 48 and this becomes 4, correct, right? Now if I multiply, so I will compare minus 1 and minus 1 into minus 48. Minus 1 into minus 48 becomes 48. So out of minus 1 and 48, which is maximum? 48 is maximum. So I will take 48 as my current max product. Then this 4 becomes minus 4. So I will compare current number minus 1 comma 4 into minus 1, which is minus 4. So minus 4 is minimum. So I will take minus 4 here. Now if you see, our 48 is more than our 6. So this is the point I am trying to say. Why we swap the numbers whenever we get a negative number? Because maybe in the next, I mean, in that particular multiplication, our most negative number can turn out to be the most positive number. Okay, so with that, now what I will do, I will update my max product to 48. Okay, so this is how we try to come up with the maximum product of the subarrays. Okay, let us look into the pseudocode now. So now n will be nums dot length. Okay, now we need current max product, or we can simply take current max, which will be easy for us. So it will be our nums of 0, then our current min, again it will be our nums of 0, then we will take our max, that will also be nums of 0. With this initialization, let us start with for loop for I equal to not 0, because we have already considered our 0 here, right? 0 for current max, current min and max. So now what I will do, I will start with I equal to 1, I less than n, I plus plus. Okay, so now what I will do, I will check if my current number is negative number. So if nums of I, if it is less than 0, then what I will do, I will simply swap, my current max comma current min. Okay, then what I will do, I will update my current max equal to max of current max of nums of I comma current max into nums of I, whichever is greater, that I will take. Then current min equal to min of nums of I comma current min into nums of I. Okay, then finally using this value, I will update my max value. So max will be max equal to, so math dot max, I mean, just not to be confused, let's say I'm using proper math dot max here. Then our max value comma our current max value. Okay, this will update our max value. Then finally I will return my max. Okay, so this all happen in only one iteration. That's why our time complexity is of order n. So this is basically linear time algorithm. Okay, now the space complexity, since we are not using anything extra, it will be of constant space O of 1. Okay, so with this, let us try to execute this and see. Okay, so here I will remove all these things. So we need constant n. Then after that, I will take let current max equal to our nums of 0. Okay, and current minimum will also be nums of 0. Then our max product. So I will take the same variable. So max product will be again nums of 0. This is our initialization. Now after this, what I will do, I will use for let I equal to 1, I less than n, I plus plus. Then what I will do, I will check if my nums of I, if it is less than 0, it means if it is a negative number, then what we will do, we will simply swap our what is this current max and current min. So for that, what I will do, const temp equal to current max, then current max equal to, so there is a spelling mistake, so it will be const current max equal to current min, then current min equal to our temp. So this is how we swap the number, but there is a simplified way of doing this in JavaScript. So I will simply comment this one. So what I will say my current max, comma. So I will say, then I will take current min. So current max, comma, current min equal to current min, comma, current max. So this way, I mean, we can use one line to swap the numbers. Then after that, once after swapping, what we can do, we can check or we can update our current max. So our current max will be math dot max of nums of I. If it is greater, it will take nums of I, or else it will take current max multiplied with nums of I. Okay, so similarly for current min, so for current min, so this will be current min into nums of I. It should be mat dot min nums of I, comma, current min into nums of I. Okay, after that I will have to update my max product. I will drag this a little bit. So finally I will update mat dot max of max product, comma, our current max. Okay, this is the code. Let us try to run and see. So if you see, it got accepted. Now I will submit my code. So if you see, our code got submitted successfully. Okay, now let's switch to editor. So what I mean, when to use the previous optimal solution, which is prefix suffix product approach. This is the first solution we discussed in the previous video. Then current one is DP approach, or it is also called Kadanes algorithm like approach. Okay, so when to use this one, so basically the first approach, it is very simple, clear and straightforward. Okay, so this solution we need to use when we only need to find maximum product. Okay, but whenever there will be a follow-up question saying also you need to find, along with maximum product, also the array which contributes to maximum product, that time you cannot really use the first approach. Why? Because whenever we get 0, we simply reset it to 1, right? We really don't know when the array which contributes to the maximum product starts. So that is highly not possible in the first approach. But in the second approach, you can find when our the subarray starts contributing to the maximum product. So we can see that maybe in a minute from now. So basically the second approach, I mean, we will prefer whenever there will be a follow-up question of finding also the subarray which contributes to the maximum product. That time we go ahead and we use this particular DP or cadence algorithm like approach. Okay, so if that is the case, then how to find the array itself? Okay, so now what we will do small modification in our code. Okay, so basically what we are doing here, so we are trying to update the current max, right? When do we update the current max? So current max gets updated based on this particular nums of I. So if this is more, then what we need, I mean, we will take this number as the current max. But if this is more, then we will not consider this nums of I. So what I'm trying to say, whenever we get a nums of I which is greater than the current max, multiplied with this particular nums of I, that is basically whenever we get 0, and after that whenever we start processing another number, that time we will consider this nums of I as our current max. It means our subarray got ended there, previous subarray. Now the new subarray starts from that particular number. So we can see this with an example. But before that, let us try to conclude this pseudocode. So what I will do a small modification here. So along with these things, I will take start index. I will take start index and I will initialize that with 0, and I will take my end index. So I will simply initialize that with -1. Then I will take a temporary start index. Temporary start index. Why? Why? Because our temporary start index will give us a reference whenever we try to get a new subarray. Whenever we get a new subarray which contributes to the maximum product. So now what I will do, I will make a small modification here at this particular point. So instead of this one, what I will do, I will check if nums of I, if it is greater than our nums of I into our current max, then what I will do at this condition. So basically I will say my temporary start index will be updated with this current index which is I. Okay, then what I will do, I will simply update my current max to current max to nums of I. If this is not the case, I will simply update my current max with nums of I. So this is one update in place of this particular line. Okay, then after this, so here what we will do, we are trying to get the temporary start index every time whenever we occur a 0. So we will see that in an example. Now after that, so here instead of doing something like this, what I will do, I will check if my current max is greater than max. Okay, then what I will do, I will, instead of this line, this particular line, what I will do, I will say my actual start index basically. So this one, actual start index equal to my temporary start index, then my end equal to the current index I. Then I will also update my max equal to my current max. This way, I will update my start index and end index. If I get to know the start index of the subarray and end index of the subarray, we can simply return whatever the subarray that contributes, right? So with this way, I mean, we can also address the follow-up question if at all the interviewer wants us to find which subarray that gives us the maximum product. With this way, we can simply give that particular subarray. Okay, so maybe what I can do, I will take this example again. assume along with this there is also 0 in between. So if there is 0, then what we need to do, actually this one we can ignore this part, correct, right? Because this really does not contribute to the maximum product. So if I want to reset something here, then I should get this reference, right? So that is what we are doing with this particular logic, so we can see that here. Now what I will do, I will start with this 0. So before that, my current max product will be 2 and current min will also be 2 and max will be 2. Now I will start with my 0. So if I start with 0, now if you see 0 comma 0 into 2, so this will be 0 only, right? So our current max product will be updated with 0, and if you see our current min will also be updated with 0, max product won't change. But now if you try to process the next number, so ideally here we need to start our subarray as a fresh element, right? Because this part really does not contribute to the maximum product. That's where if I start here, then my start index should start from here. That's what it does. So now if you see 3 comma 3 into our current max will be 0, so it becomes 0. Out of 3 and 0, 3 is maximum, right? So this is basically nums of I. So in that case I will update my start index here, correct, right? Then I will take 3 as my current max product. So this is how we use this particular logic to find where exactly our subarray starts. Okay, hope I was able to explain this concept well, and I feel that, I mean, you understood this concept. Maybe if you don't understand, please take one or two more examples and try to simulate this and try to um, uh, understand the idea behind this particular problem. So with that, maybe if you have any other queries, you can add that as a comment. And if you have understood this well, please add that also as comment. And please consider subscribing to my channel and also like the video, share this with your friends. And thanks for watching.